going to continue our class from where we left last time. We're going to start with the very topic which is just after the previous class. The name of the topic is electric field. Electric field due to a point charge. Due to a point charge. Actually, this is a small derivation, a very short derivation, and you will need a particular diagram. As the name suggests, there should be a point charge. Let us say the point charge is Q and it is kept at the point O. Then at the distance R, let us take a point P which is at the distance R. Then, as you know, the source of electric field is nothing but a point charge. A point charge is a source of electric field. I suppose you remember the definition of electric field. Then you are going to find the electric field at this point P. If it is a positive charge, then by definition of by property of electric field, it should be field line. It should be starting from the positive charge. It should be directed towards the right side. So this is the direction of the electric field intensity or electric field line at a point P. So for the sake of simplicity, let us place a test charge Q naught. Test charge. What is Q plus Q? Plus Q is the source charge, which means the source of electric field, and Q naught is the test charge. Where it is placed? It is placed at the point P. Point P the time. Plus Q is the source charge ni, Q naught is the test charge ni. The distance there should be a distance of R. Assumptions I will give you in a note properly. Just start with the Coulomb's law. From Coulomb's law, what should be the force between them? As you recall, Coulomb's law, according to Coulomb's law, there should be a Coulomb's constant K, charges Q naught, and distance is distance square. So let this be the first equation. And this is just the Coulomb's law. Two charges, instead of Q1 and Q2, you have Q and Q naught later. The distance R later, Coulomb's law is easy. Then by definition of electric field define E is equal to force per unit test charge. This is what you have learned. And a force per unit test charge force divided by test charge Q naught. This will be done. Then let us use the particular equation 1. Let us use this expression and substitute here. Then 1 by Q naught should be there into K Q naught divided by R square. Then Q naught can be cancelled. One is at the denominator, one is at the numerator. Then what remains? Q by R square here, instead of K, what you can write? 1 by 4 pi epsilon naught Q divided by R square. So this particular equation is the expression for electric field due to the point charge. So the final expression here, on which factor does electric field depend? Electric field is a factor that depends on it. It depends on the magnitude of charge, and it depends on the distance where you measure the electric field. It depends on the medium also. Vacuum the charge epsilon naught. If it is kept in any other medium, then for that particular medium we are going to use the value of absolute permittivity. Water the thamtagadi, we are going to use absolute permittivity of water. Right? This particular expression is the electric field due to the point charge. Now, after knowing this, let us see the significance. Significance of what? Significance of electric field. Significance. Significance of physical significance. Significance of electric field. Electric field. Let us go to the physical significance of electric field. By definition of electric field, it is force divided by base charge, or if you have the vector quantity, it should be placed like this: force F vector divided by the base charge Q naught. This is the definition of electric field intensity, or simply electric field has if you find this F vector, how much you get? Q naught E vector. Q naught E vector. This is what you have. From the definition of electric field intensity, if you find force, it is Q naught times of E vector. Then let us try to think of a suppose you have a uniform or non-uniform, it may be that for the sake of simplicity, it may be a uniform electric field. This is how a uniform electric field is drawn. Uniform electric field this charge Q naught C this charge Q naught. Q naught is placed in the electric field. Then, if it is a unit positive charge, if it is a positive charge of the target, charge will be moving in this direction due to the electrostatic force, C force in this F vector will be in the same direction if it is a positive charge, positive test charge, same direction with E vector. But if it is a negative charge like this, minus Q naught over the target, is a rare. So we can this F vector. Let this be F1, let this be F2. Why? Because if it is positive, the plus lakani. If it is negative, there should be minus sign. Then if it is positive, then force and electric field are in the same direction. If it is negative, then electric field and force they will be in opposite direction. what is the physical significance of electric field haiba taragadi aikoina haigadurisi kaino haiba kanda it signifies the force. It signifies the force, either it may be F1 or F2, which is to be experienced by a unit positive charge when kept in the electric field. Aside the electric field to the unit positive charge to thammakana mana experience the force to madu to signify the way high. Let me repeat again. The physical significance of electric field intensity is the force which is to be experienced by a unit positive charge when placed in the electric field. Aduna see significance important oi. So let me write down. The physical significance of electric field is the force experienced by a unit positive test charge when placed in the electric field. So this is the physical significance. If you are asked to write the physical significance of electric field, then you should write it like this. Then after knowing all these concepts, the concepts in there will be another term, another quantity, which will be very much essential in classification of the molecules. Say, let us come to electric dipole. What is di? Di means two. Pole means it relates with the charges. Then electric dipole have say plus Q minus Q. Equal the charges. These two charges have same magnitude but opposite in sign. These are equal and opposite charges. So my equal and opposite charge certain distance of separation twice A high lower C. Twice A is the distance of separation between the two charges. Then such a system in which the two equal and opposite charges are separated by a small distance of separation. This should be of the order of centimeter. Twice as is centimeter की order de lege daune. Adu ebe target such a particular system is known as an electric dipole. So an electric dipole will be defined as the system which consists of two equal and opposite charges separated by a small distance of separation twice A. Okay, then see the direction of the the dipole length will have a particular direction. If this is a twice A vector, then it should be twice A vector should be directed from minus Q to plus Q. Unlike electric field, in electric field the direction of the electric field is directed from plus Q positive charge to negative charge. However, in this case, this dipole length, this twice A vector is known as dipole length. this dipole length will be directed from minus q to plus q. Minus q to plus q. This is the dipole length. Then there is a very important term which is known as dipole moment. Actually, electric dipole moment. Dipole moment. By the term electric dipole moment, you will define as the product of magnitude of either of the two charges. Charge and is magnitude kya hoy? Q ngata ni. One is plus q, another one is minus q. Magnitude of either charge si kya hoy re? Q hoy re. Then what is the dipole length? Twice a vector. Twice a vector. Then such a product of an electric dipole, this is known as electric dipole moment, denoted by small p vector. So this is how you define an electric dipole moment. An electric dipole moment is defined as the product of magnitude of either charges, that is q, and the dipole length twice a vector. Obviously, what should be the direction of the p vector then? It should be having same direction with twice a vector. Twice a vector की direction सिगा dipole moment vector C p vector C mai keno सिगा मसी same direction दा लेके दो. That having actually this p vector must also be directed from right to left. Minus q degi plus q on the second. Then if you write only the magnitude khatang I bataragadi p khatang I ke hai bataragadi ke dawani adudi twice a q can be written. So this is the magnitude of the electric dipole moment. Electric dipole moment is magnitude. Then let us think over the SI unit of dipole moment. SI unit. These units are very important. SI unit of dipole moment. SI unit of dipole moment. What is the unit of charge? Coulomb. What is the unit SI unit of distance? Meter. Coulomb meter. So C should be written in capital, M should be written in small. So this is Coulomb meter, and this Coulomb meter you cannot write it as MC. You might be thinking this is also Coulomb meter, but it cannot be written in the unit of electric dipole moment. You cannot write MC. That is because MC will signify millicoulomb, which is not equal to Coulomb meter. Millicoulomb high. Millicoulomb means how much coulomb? Milli means 10 power minus 3 coulomb. So let me ask whether electric dipole moment should be a vector or scalar. Vector quantity oigadra natraga scalar quantity oigadra. You should look over this very definition of electric dipole moment. See definition study. Twice a vector has a vector quantity. It has magnitude as well as direction. Q has the electric charge. Electric charge is just a scalar quantity. Then when a scalar quantity is multiplied on a vector quantity, it becomes a vector. So you might have learned in class 11 the multiplication of a vector by a scalar is always a vector quantity. Aduna, this dipole moment, electric dipole moment, is always a vector quantity. Now, let us know the significance. Significance, that means importance of this electric dipole moment. See, matter consists of so many molecules. As you know, molecules as a whole, molecules are electrically neutral. That means the number of positive charges contained in this particular body is equal to the number of negative charges. Almost all the matters around us are electrically neutral. That is because they consist of a particle single. Particle single molecule single. Molecule single electrically neutral. Almost every object around us are electrically neutral. Aduna, classification of the molecules can be done. Classification of molecules or substances can be done by using the concept of dipole moment. See, or electric dipole. See, let us take a few molecules. Water molecule, ammonia, NH3, ammonia, then hydrochloric acid, HCl, then let us take hydrogen, oxygen, nitrogen, chlorine, etc. So in such type of, let us take the example of this hydrogen. In a hydrogen, there are two hydrogen atoms. Two hydrogen atoms are like this, and one oxygen atom. You might learn in chemistry, and there should be a bond angle between them. And as you know, hydrogen is positive charge, and oxygen is negative charge. You know, then equal to very much similar to what you have learned. There consists of equal and opposite charges. However, in case of hydrogen, you will have same molecules of the this hydrogen molecule consists of only hydrogen atom. Hydrogen, one is positive, other one is also positive. Hydrogen atom. In hydrogen molecule, there consists of two positively charged hydrogen molecule. Then hydrogen atom sing the atom submanaba monoatomic oiba adugu molecule. Adu iba such a system, asiguma system it consists of equal and opposite charges. Equal and opposite charge like asidadi like. Then kalidoroni. Then these molecules will have dipole moment. Dipole moment like they will possess dipole moment. That is dipole moment like P vector should not be equal to 0. It should possess dipole moment. However, in this type of molecules, dipole moment should be dipole moment. In case of hydrogen, oxygen, nitrogen, etc., that this dipole moment will not be there. How this classification comes? Let us see. Why the dipole moment becomes 0 in some of the molecules, and why it is not 0 in some of the molecules. See, the first example that I gave you were called polar molecules. In polar molecules, just like what you have, I have just written, ammonia, water, etc. In such polar molecules, in simple representation, what it look like in one molecule of the polar substance, the center of the positive charges and the center of the negative charges, they are not at the same position. Then there should be a certain distance of separation between them. Then it just looks like an electric dipole now. Electric dipole the mong the Then that's why such molecules are known as polar molecules. polar molecules. And the dipole length, this twice A, will not be 0. If there is certain distance of separation between the positive charges and negative charges, then this dipole length will not be 0, then obviously P will not be 0. Alright. But in case of non-polar molecules, what happens is, in one molecule of the polar substance, non-polar substance, the center of the positive charge as well as the center of the negative charges, they are in the same position. Center of positive charge ka center of negative charge ka che, they will lie in the same position. Then dipole length twice A will be 0. If they are at the same position, distance between the positive and negative charges will be 0, obviously. Then by the definition of your dipole moment, twice A Q ni. Then obviously if twice A is 0, then P should be 0. Right. So this dipole, concept of electric dipole, plays a very significant role in the molecules to signify them. In all types of molecule can be classified under these two categories. One is polar molecule, one is non-polar molecules. Then how will you define polar molecules then? In polar molecules, the center of the positive charges and center of the negative charges, they will not coincide. Right. However, in non-polar molecule, the center of the positive charges coincides with the center of negative charges. Coincide to same